Hello, this is Karen Timberlake Basic Chemistry. We're in Chapter 8 and Section 1 on equations for chemical reactions. So, first of all, we have to be able to identify whether something has reacted. A chemical reaction usually has some kind of an indicator. Something will change. What's happened is that when you have a compound where you actually are sharing electrons, two elements or more elements are sharing electrons, or they've stolen electrons and they're bonded together. The thing that's true about that new material is that it has new properties. There might be a new color, it might have a new density, it might have a new boiling point, there's something that you can look and observe about it. There's properties that you can look. And when something changes, there's new properties. If it doesn't change, you're going to have the same properties that you had before. The same color, the same density, the same everything. But if you do have a change, if there's been a chemical reaction occur, you can detect that in some ways. Sometimes you need to be a little creative. Other times it's very obvious. Okay, and so we'll look at today some of the ways you can tell that there's been a chemical reaction, and then how do you write that chemical reaction down? And so that's what an equation is, equal coming into the word equations. Okay, so reactions is where two or more elements are reacting together, bonds have been broken, and new bonds have been formed. So they're sharing electrons or they've stolen electrons from each other, and then they're attached together with properties. Okay, so we'll look at all those today. So first of all, you've got something new properties. You also have different compositions. So for instance, peroxide is H2O2. So two hydrogens, two oxygens, all of those elements are sharing electrons with each other, and you actually have a combination of elements in a little grouping. Okay, peroxide has certain properties. Okay, you know that it bubbles, you know that it's clear, you know that it's liquid. Okay, so there's stuff that you know about it. Well, the reason why peroxide bottles in your medicine cabinet are brown is because light, if it were to go through that bottle, can break that peroxide down into water. Okay, so the bonds break, the bonds between the hydrogens and the oxygens break, then new bonds form, and at the end you end up with H2O plus some hydrogen. So hydrogen gas actually breaks apart from the peroxide. It's not that hydrogen gas was in the peroxide, it's that peroxide was made of hydrogen and oxygen, and if all the bonds break, think of them like Legos, if they all break apart and then new bonds form, so at the end you end up with water and hydrogen. Okay, so that's a reaction. So you have different compositions, different properties, and during that time you know something has happened. So the example here is you have a silver fork, and you've got sulfur in the air. The sulfur reacts with the silver to form a silver sulfide, and that is that black gross stuff that is tarnish, the tarnish of the silver. So that's an indication of a chemical change or a chemical reaction because you have a color change. So something new is being produced. So in a chemical reaction, you have something different at the end than you had at the beginning. Okay, and there is a change in composition of all the elements or some of the elements. So for instance, the H2O2, water has H2 at the end with one oxygen. Peroxide has H2 with two oxygens. Suddenly now that difference in oxygen is a difference in properties. I wouldn't drink peroxide if I were you, but you can drink water. It's not a problem because these compounds now have effects. They can do things like poison you. Please don't be poisoned. So new substances are made with new properties. So if you write this down, please, these are some indicators that there's been a chemical reaction. First easy one is that it changes color. Okay, so if you put two clear liquids together and all of a sudden it turns bright orange, you've had a chemical reaction. Something is different because the properties, like for instance color, is different than it was at the beginning. If you form a gas, So if you have two liquids together and all of a sudden you've got bubbles, all right, or if you were to say pour acid on a piece of limestone and it bubbles, that is an indicator that there is a chemical reaction occurring because you're getting a product that happens to be a gas that's making those bubbles. Also, if it changes temperature, if the reaction gets hot or cold, okay, so I can put two chemicals together that are total normal room temperature, just pull them off the shelf, put them in a test tube, and they instantly boil. You don't even need to add energy. The energy is automatic inside the test tube. Immediately gets boiling hot. You can have there's heating, like hand warmers that you can get when you're hunting, where just little plastic packages with chemicals in them, and you crush the package, and inside the chemicals mix, and all of a sudden there is heat coming out of that, and you put it in your pocket and keep your hands warm. You can also do that with cold. You can have cold packs that you put in the first aid kit, and you take the little packet, you crush it. You don't rip it apart, but you crush it, and the chemicals mix inside the packet, and all of a sudden it turns cold, and it would be like an ice pack you would put on your leg. All right, so here's your first example. Identify the visible evidence that a chemical reaction has occurred. Okay, methane gas in an outdoor heater burns with a blue flame. Well, burning is a chemical reaction. Okay, oxygen is coming in from the air and reacting with, in this case, methane gas, and producing carbon dioxide and water vapor and heat. So you have to keep that in the back of your mind too. This is not just elements changing to elements, but heat, energy is changing. Okay, so that's just as important in chemistry as the stuff is the energy that's changing. Bleach removes stains from a shirt. Well, that's a color change. So there has been a chemical reaction. Okay, that sodium hypochlorite, which is Clorox, has reacted with whatever the chemical compound is in the stain, and it bleaches the shirt. Bubbles of carbon dioxide are released when baking soda is mixed with vinegar. You've got an acid and a base, and you end up with some carbon dioxide gas, and that bubbles that are coming out from that liquid is an indicator that you're getting a reaction. All right, so a chemical equation, right? We've talked about a chemical reaction. A chemical equation is a way to show you what's happening in a chemical reaction. So I need to write down all of the stuff at the beginning. I need to write down all the stuff at the end, and it needs to show you it's equal. All of the material at the beginning is the same stuff as at the end, same number of Lego blocks, but you put the Lego blocks together in different combinations. So you have first combinations of Legos at the beginning. Those are your reactants. You break them apart. The energy comes out, and then new energy is required to make the new ones. So you end up with either releasing some energy or absorbing some energy from the environment, and with new product. So here you have some charcoal. Charcoal is being burned. Okay, so you have carbon and oxygen. Carbon is from the charcoal, the oxygen's coming in from the air, and it ends up making carbon dioxide gas. So that is your reaction. Carbon plus oxygen yields carbon dioxide gas. And you also realize that there is heat coming off at the same time. So there's energy change as well as an element combination. So the symbols that you use in a chemical equation, you have an arrow. That's showing you that it's going to produce something. It's yielding something. So you have reactants on the left. Those are the things you start with. Those are your building blocks. You have products on the right, things you're producing. The plus just means you're putting two or more reactants together, or you're producing two or more products. The delta, which is a Greek capital letter D, it means that it's heated, that in order to get this reaction to happen, you had to kind of bump them together very fast and rough, and you do that by heating, giving it energy. And then the other ones in parentheses just tell you what phase it's in. Is it a solid? Is the reactants a solid or a liquid or a gas? And then AQ is aqueous. Is it dissolved in water? That's what aqueous means. So do you have something like salt where you put it in the water and it actually doesn't stay as sodium chloride, it breaks apart into sodium ions and chloride ions. And so that's what aqueous means. In a balanced chemical equation, and this is what we're going to do next time, in a balanced chemical equation, you have to make sure that all of the material is the same amount on both sides. All right, so you have the same amount of Lego blocks at the beginning, same amount at the end. You can configure them in different orders, but they have to be exactly the same. And so by doing that, you're showing that you didn't make matter. You can't make matter by stirring sugar in your coffee. That doesn't make anything. You only take what's there, and it changes composition, and that's all. So chemistry doesn't make anything, and it doesn't destroy anything. It only takes the building blocks and reconfigures them, separates them from each other, and reconfigures them into a new design with new properties. And that's what that is. So in the next lesson, we're going to break this apart into 2 lessons. In the next lesson, I'll talk about making a chemical reaction and balancing it. How do you make sure that the same amount of stuff is on both sides? All right? I hope you're doing well.